Are we good? Are we good? I feel like I'm on a WebEx call and it's like, can you hear me now? Is my microphone on? Can you hear me now? Is that the thing we say the most these days? Can you hear me now? Hey folks, my name is Patrick Gargano. I work with learning and certifications. I'm an instructor, I'm a content developer. I work on the team that develops like the CCNA content, ENCOR and ENARSI. I don't know how familiar you are with our setup. We've got content people like me and then the exam people, right? I'm here to talk about content to help you get ready for the exam. So I work on all of the like enterprise stuff, SD-WAN, as I said, CCNA, advanced routing. And, we give the CCNA a lot of love at at all these conferences, and I feel like there's some others that don't get as much love, and so I wanted to create a session for those other certifications. So I don't know, is anyone thinking of doing it while they're here, or they're planning very soon to take the ENCOR exam? Maybe a little fantastic. Anyone thinking of doing this one either here or very soon as well? A couple of people, great. So as I said, if you're already thinking of taking that exam, you're probably already familiar with some of this. So it'll be just a nice little refresh of what you should know relating to OSPF, specifically OSPFv2. The LSAs, I know there's lots of them. I'm going to focus on 5 specifically, right? The 1 through 5, the classic ones. And then we'll have a look at those special OSPF areas as well, the 4 of them. And then I put together like a little demo. Instead of doing it live, I took basically a little topology. And then as I would deploy the different areas, took the routing tables. And so we can kind of work through them to see what happens in those routing tables when we turn on these areas. What else do I have for you here? Okay, so at the end, I'm going to do a draw. I brought one of my Cisco press books. It's a 31 days prep book for those that are thinking of taking the ENCOR exam. So maybe if you are thinking of taking the exam, at the end of the session, we can maybe just go around the side here and we can do a little draw just with those, because I would really like the book to go to someone who will actually use it and not just sit on someone's shelf. So again, if you're thinking of taking ENCOR, and listen, if you're, same thing for ENARSI, there's a lot of stuff in here that you need to know for ENARSI as well. So at the end, let's just huddle on the side here. We'll do a draw for a copy of my book. I'm French Canadian. I know you probably can't detect my accent in French, but that's okay. What we do in Quebec in Canada is we make a lot of maple syrup. And so what I do typically when I go to Cisco Live is I check with the government to make sure that it's okay. And I get permission, I'm just kidding, to bring some maple syrup candy with me from Canada. So we're not a lot of people, so I'll be able to, I think, hand out quite a bit of the candy. Usually I hand it out if you give me the correct answer to a question I ask. But I think the idea is I brought a kilo of it and I don't want to bring it back to Canada, right? So I just want to like give it all away. So it's quite nice in coffee. So you can drop it into your coffee and it's quite lovely. So I'll be giving out that as well. Okay, so here we go. As I said, we'll look at the LSAs initially, then we'll look at the areas, we'll do like a little walkthrough of a scenario, and then I'll do the Cisco Pressbook giveaway. Before we jump right into the LSAs, I know this is a bit of review. Hopefully you know this already. How does OSPF work? Why do we call this a link state routing protocol? So I just kind of pulled a couple of ideas out from some of our content to just remind you what's happening with OSPF. So obviously we know that we need to exchange hello packets to establish a neighbor relationship. We know that, that's fine. Once that happens, we're then gonna start advertising LSAs, which are gonna carry the routing information, right? The prefixes that we need to advertise throughout the network. And we know OSPF does some interesting things like all the routers in an area have the same database of information, right? They have to be synchronized, so we know about that as well. We know that OSPF is a little funny, right? It'll flood, it'll multicast that area with those messages as well. So hopefully this is all coming back to you. And then, as I said, it's going to then take those LSAs and build what we call the link state database. And I don't know if you've ever thought of the name link state. Why is it, right? We have distance vector. Why is it called link state? And I like this little diagram. I think it's pretty clear. When we talk about the link in link state, we're just talking about the actual interface that's connected to a network, right? Or another router maybe. When we talk about the state, it's what's that relationship like, right? Is it maybe multi-access? Is it point-to-point? What type of neighboring router is there that I have my connection with? So that's what they talk about when we mean a link state routing protocol. And then, okay, first piece of candy. Once we have all the LSA information in the database, what is the name of the algorithm that OSPF uses to determine the best path in the network to reach a prefix? Come on. Okay, let me re-ask my question. I can see we've got some confusion. My bad, my bad. What's the name of the gentleman? There we go. Thank you very much. That's what I was looking for. Dijkstra algorithm, right? It's this mathematician who came up with the idea of being able to figure out the shortest path in a tree of different possibilities. And obviously, at the end of the day, what is OSPF doing? It's building a routing table for us with the prefixes for the destinations. And not just any destination, right? It's the remote networks. It's the networks that we're not directly connected to. That's what we need to learn. Okay, that was like a 2-minute, very, very brief refresh on OSPF. I really like this diagram as well. This is a really nice, and again, we're going to do a little deep dive into each one of these, but I just wanted to start with this one because it just kind of gives you a visual of where these LSAs are that I'm going to be talking about and where we can find them specifically. And as I said, in this 30 minutes that we have, I wanted to talk about LSAs type 1 to 5, which are like the traditional kind of basic ones. We'll talk about 7 a little bit later on, but I want to focus on 1 through 5. And the only thing I really want you to take away from this one initially is, as I said, where these LSAs live, where you find them in the OSPF network. So if I look at this diagram, I can see there's some LSAs called type 1 and type 2. Okay, not quite sure what they do yet. We'll have a look at that. Apparently, you'll find them in an area, and you'll find them in the backbone. And basically, here's the tip. You'll find them in all the areas. And we'll see why they're so important, right? That's like the fundamental LSAs, the 1 and the 2. The point that's trying to make on the diagram, though, is that the type 1, type 2 LSA that lives here doesn't go over here. And the ones over here doesn't go over here. What we use instead are these ones, the type 3s. So what we're going to see in a few seconds is the type 1 and 2, for it to pop out of here, it's going to get converted by this router into a type 3 LSA. We'll see about that. Another piece of candy here, maybe. What do we call the router that's sitting between areas in OSPF? Sorry? No? What do you, hang on, we got someone over here. What? ABR, here's the candy. ABR, area border router. Very good. And then there's some other stuff that happens down here with some other LSAs, type 4 and type 5. They kind of work hand in hand, these ones. And they get triggered and kind of created because of the existence of this router over here, which obviously I'm going to ask you what the name of that router is, that is sitting between OSPF and maybe EIGRP. What do we call that one? ASBR? There we go. Thank you very much. Autonomous System Boundary Router. This is the router where you will type the command redistribute. If you redistribute something from the EIGRP, a static route, a connected interface, into OSPF, automatically that router becomes an ASBR, and it starts advertising those routes with a type 5 LSA. Now you'll notice I skipped one. It's this one over here. What's this one all about? Well, we're going to see in a second. The type 4 is basically advertising to the rest of the OSPF network how to locate this ASBR. Now you might be wondering, yeah, but hang on, Patrick. The ASBR is here, but the type 4 is kind of taking off from this device. What's going on? Well, don't worry about it. I didn't make a mistake. This one will advertise itself as an ASBR with a type 1 LSA, which we know, as we said here, lives in here. So there's an LSA that's going to get propagated in this area by this guy. He's going to say, hey, my name is R3. I'm an ASBR. I'm over here. That's a type 1 LSA. It's a special type 1, but it's a type 1. When that type 1 LSA hits this router is going to flip that. It's going to change that LSA into this special type 4 LSA. So that's why it's not a mistake. That's why this arrow is starting at this point. Is that okay for just a little visual of what's going on? So we're going to have a look. I'll have a slide for each one of these, and then we'll get to the areas. All right. One of the things that I get often as a question is, Patrick, how do I remember what the difference is between all these different types of LSA? So I've tried to come up with a cute, clever little trick for each one of these. So kind of bear with me, and it's almost like a dad joke, but bear with me here. Okay, so what's a type 1 LSA? Where do we find them? Like I just finished saying, if this is my network over here, area 10, 0, 20, I've got type 1 LSAs flowing in here. They're going to be flowing in here and flowing in here. They're not going to get out of here, and they're not going to go into there. We're going to use something else instead. As you can see by what I'm talking about, what is it going to include? It's going to include information about who I'm attached to. It's going to have router ID information of the device that's advertising that LSA. basically, I think the key sentence is the one at the top here. You're going to have one of these for every router in an area. It's going to flood within the area. It does not cross the ABR. So my tip of the day here is that a type 1 LSA, you'll only live and only see it within that one area. All right, so there's some here in this area, there's some here in this area, there's some here in this area. It will carry prefix information, but just for very specific types of OSPF networks. If it's a multicast or multi-access network, it won't have the prefix. It'll have subnet mask information. But besides that, that's what the type 1 is. It's basically saying, hey, I'm in this network. Here's my router ID, and here's what I'm connected to. So if I have multiple routers in here, and I do a show IP route, those type 1 LSAs would show up as an O in the routing table. Does that make sense? So if I've got a lot of routers, a lot of networks connected to those routers, I do a show IP route, whatever I learned through a type 1 LSA would be with an O in there. There you go. That's it. The type 1 LSA in that one area. So what's up with the type 2? Well, oh, hang on. Before we go to type 2, you're probably wondering, okay, I'm going to be doing an exam. I need to maybe be able to figure out how to deconstruct the information from a show command. So if ever you want to build a lab environment, for example, let's say you build that in CML, right? A couple of routers, and you logged into this router over here, and you did a show IP OSPF database router. So just to look at the type 1 LSAs, you kind of see this kind of information. So right now, it's showing me two type 1 LSAs, one that's being advertised by 10441 and then one by 10442. Now, I didn't want to put the addressing on the diagram. This was getting too small, but here it is. I kept it as simple as possible. This network is 1011, 1022, 1033, 1044. Got that? Try it again. 1011, 1022, 1033, 1044. So what are we finding out? That these two routers, one is 10442, the other one is 10441, are advertising a type 1 LSA in area 20. And that's what's in the database for that particular router. And we can see that, interestingly enough, the 10441 in the type 1 LSA is advertising itself as an area border router. We know that, right? We know that this router is an ABR sitting between the backbone and area 20. So if ever you're in a Cisco exam and they're asking you questions about the show IP OSPF database command, this is how you kind of start pulling out that information that's critical here. Obviously, it's telling us that it's also connected to an Ethernet connection here, so it's got a DR and a BDR connection possibly as well. But anyway, I just want to kind of point out what we see as a link state information for the type 1. How about the type 2? Well, the type 2 is a very specific type of LSA. You'll only find it on a multi-access environment or network. In other words, if you have a switch with multiple routers connected, or as in my case, two routers connected with, let's say, an Ethernet connection, right? So there's no switch, but it's still Ethernet, so it's considered multi-access. Automatically, as soon as OSPF says, hey, hang on a second, this is a multi-access network, it's going to start wanting to advertise type 2 LSAs. But I'll be honest, it's not all the routers that are going to do that. Which router is going to advertise the type 2 LSA? The answer's there. Which router advertises a type 2 LSA? What was that? What? So the DR is going to advertise that. So what happens is I've got a network. Let's say this is a little network over here. Imagine there's a switch. These two routers are connected through that switch. There's going to be a conversation here that's going to happen. We're going to elect a designated router. We're also going to elect a backup designated router, but let's put that one aside for a second. The designated router is going to advertise itself as the boss on this multi-access network by advertising a type 2 LSA. So this is what we're talking about here. One network LSA. It's called a network LSA for that within the area, right? Notice I stopped the arrow here, right? It's not popping out. It stops right there. Advertised by the DR. Here's my dad joke tip of the day to remember what this one is, right? Type 2, the number 2, 2 letters, DR. Very good. My 16-year-old approves of my dad jokes, by the way. This is going to include information about all the routers that are attached here within that multi-access network. Again, doesn't cross the ABR, and it will also appear in the routing table as an O entry. So if I log into, if I go back to my little router over here in area 20, which I know is connected, I'm letting you know, when I built this in my lab environment, it was just an Ethernet connection, so I knew it would generate a type 2 LSA. If I do a show IP OSPF database network, to just look at the type 2 LSA, I can see that in this case, it looks like there's a type 2 LSA in area 20. It's being advertised by the 10441 router, right? Which is the designated router. I got information about the mask for that network and who's attached to it, right? So if there were multiple routers, it would say, here's all my friends that are on this multi-access network. In this case, there's only two, the 10441, which by the way would be the address here, and 10442, which is the address there. That makes sense? So type 1, type 2 LSAs, they're not super exciting. I mean, they're critical, they're important, but I think we start getting into the more exciting stuff with the 3, 4, and 5. 3 is probably, honestly, I mean, it's probably the most important one in a large OSPF environment. This is the type of LSA that you're going to see a lot of because this is the one that's allowed to travel from one area to another area. We call this one the summary LSA. And this is the one, as you can see, that's going to be allowed to flood. And I like the diagram, right? Hopefully it's bringing it all together for you. Type 1 and 2 lives over here. It hits the ABR. The ABR is told, okay, I need to let everyone else know about what's going on over here. It's going to flip that information into a type 3 and then start flooding that across the backbone. And if you don't put any filtering in place, it's going to keep flooding all the way into all the other areas as a type 3 LSA and be regenerated or re-advertised by those ABRs into those other areas. So it's going to describe all the networks, right? So if I had a bunch of networks here, like 192.168.1.2.3.4.5, right? It could hit this guy and it's going to keep advertising that throughout as a type 3 LSA. My dad joke way of remembering what this type of LSA does. So type 3 is a number 3 letters, ABR. So this is being generated by the ABR and then flooding through the entire network. So thank you for approving of my dad joke way of figuring it out. This is really important. I just mentioned it, but I just want to say it again. So as this LSA is flooding, it's going to get regenerated or re-advertised by this ABR. So basically it's going to say, hey, I'm letting you know about the existence of this. Although it didn't come from me originally, I'm the one who's letting you know. And this is important because when this router needs to get over here, it needs to know who to talk to be able to get that way. This is where things get interesting in the routing table. If I do a show IP route and I start seeing OIA entries, right away I know that that's a type 3 LSA. It's carrying information about prefixes outside of my current area, and I'm learning it through a type 3 LSA. Let's have a look at the show command. Show IP OSPF database summary. Again, I'm using that little topology here, and I'm just focusing on what we see on that router. I'm running out of real estate on the slide here, so I'm sorry it's a little crowded. But what it's showing me is that for this internal 2, which is that router, it's got 3 type 3 LSAs. 1, 2, 3. 1 for the 10.1.1 network, 1 for the 10.2.2 network, and 1 for the 10.3.3 network, which is beautiful. That's exactly what I was expecting, because don't forget I told you, this network is 10.1.1. That's 10.2.2, that's 10.3.3. So this router has learned about the existence of that, and that, and that, thanks to these type 3 LSAs, and they're being advertised, they're being regenerated, if you like, from the advertising router 10.4.4.1, 10.4.4.1, 10.4.4.1, which is this guy. Nice, like magic. Obviously, I've got metric information as well, which is interesting. Have a look at this, right? So the 10.3.3 is this network, got a cost of 10 to get there, because these are all Ethernet links. So it's got a cost of 10 by default. The 10.2.2 network has a cost of 20, which makes sense. It's almost like a hop count at this point, right? 10 plus 10. And then the next one is 30. 10 plus 10 plus 10 to get there. There you go. How are we doing so far? Good, okay. The type 4 LSA, like I said, it's a funny LSA. It will only exist if you have an ASBR. So if you build a little network in CML at home and you don't see a type 4 LSA, it's because you haven't deployed a router in which you're redistributing into OSPF. So if you haven't done that, you won't see type 4s or type 5s. But as soon as you do that, as soon as you type under OSPF, redistribute, connected, redistribute, static, redistribute, EIGRP, redistribute, BGP. As soon as you do that, this guy becomes an ASBR. It will immediately start advertising itself as a type 1 LSA with a special bit kind of enabled, called the external bit. That's going to hit the ABR. The ABR is going to take that saying, okay, this is important information. I need to flood this. I can't flood it as a type 1. I need to flip this into something else. I'm going to flip it into a type 4 and boom, it's going to flood. And all this LSA is saying is basically, hey, I'm over here. It's basically advertising the existence of the ASBR and the cost. How much will it cost to reach that ASBR? Because you might have multiple ASBRs, right? Multiple exit points. So we need that cost information to make the correct choice for the path. What does that look like in the show IP OSPF database? It's very short output. Why a very short output? Because I only have one ASBR. And again, I'm looking at it from the perspective of this router over here. So that type 1 LSA was generated, flipped to a type 4. I did a show IP OSPF database ASBR summary over here on that router. I'm seeing one entry. There it is. It's basically saying, hey, this is an AS boundary router, and it's being advertised to me by 10441, which makes sense, right? That's the ABR here. That's advertising it. And this is the router's ID. The router is 8888. I just created a loopback. Basically, I created a loopback on that router and did a redistribute connected. So that's how it became an ASBR. And I just gave it the address 8888. You got a metric of 40 to reach that, right? 10, 20, 30, 40. No, sorry, let me try that again. 10, 20, 30, 40 to get to the ASBR. So there we go. That's the type 4 LSA. So it's not super exciting, but it is critical to let me know how to reach that router. What's more interesting, though, is when this device starts advertising networks, right? So if this was a huge EIGRP deployment and I redistribute the whole thing into OSPF, I'm going to start injecting a ton of type 5 LSAs. The type 5 LSAs are what we call external LSAs. They're going to carry the prefixes that exist outside of OSPF. I forgot my dad joke for the type 4. Hang on a second. Type 4. What's the dad joke here? 4, the number 4, 4 letters, ASBR. Not bad. My son approves. Okay. And the thing that gets interesting also in terms of the routing table is that as you inject these external routes, they're going to start appearing using this kind of naming in the routing table. By default, it'll be an OE2, external type 2, where the metric doesn't increment, but you can change that to an OE1, where the metric will then increment. And why would you want to change it from one to the other? It depends if, as I said earlier, if you have multiple exit points, multiple ASBRs, you want to use the closest best one for a specific location. Show IP OSPF database external. Again, I'm on this router over here. As I warned you, the only thing I did when I created this in CML is I went on this router, I went interface loopback 0, IP address 88888, and then I redistributed that into OSPF. So that means that's why I only have one type 5 LSA. My type 5 LSA is basically saying it's being advertised by the 8888 router. It's an external link. There's a /32 on that. I've got the type 2 by default with a 20 metric as the default as well. And this, ladies and gentlemen, is flooding throughout the entire network at this point. Right, because by default, there's no filtering. You could deploy some filtering. If you're studying for ENCOR or ENARSI, there's a huge amount in those courses around filtering, routing updates for EIGRP and OSPF and BGP. So you need to make sure you study that quite a bit. Sorry, my dad joke. Where's my dad joke? It's not the best dad joke. Did I take? Oh, I removed it. So the only thing I could come up with for this one was type 5. I was like 5 letters. OTHER, other networks. Type 5. It's not as good. I know. It's not as good as the other ones, but it's as good as I can. All right. Is that okay for everyone? Very quick run through of the basic types of LSAs. Okay. Let's get into the fun stuff here. Got 5 minutes left. Jeez. I wish these sessions were longer. No. Okay. There's 4 of these. They have the most hilarious names, right? I think we all agree. 2 of them are like the standard areas that were created with the RFC, with the original standard of OSPF, the stub, and the NSSA, which means not so stubby. And then Cisco has kind of like its own version or its improved version of that, which we call totally stub and totally NSSA. And I mean, this is not complicated. All we're trying to do is help routers that are in a in a cul-de-sac, right? We've got areas in our OSPF network where we have one way in, one way out. We have a router on the edge there of that area, and we want to minimize this routing table. It doesn't need to know all of the prefixes for the entire OSPF network. So I want to shrink. I want to help the OSPF database get smaller and the routing table get smaller in those particular ones. So let's have a look at the stub. The stub is pretty straightforward. So if here's my area, I've got EIGRP, I've got a regular area here, my backbone is over here, I've got area 50, and I've now configured it as stub. What happens? It's not complicated. It's going to filter out external routes. So type 4s, type 5 LSAs are going to be blocked. So that means that if someone over here wants to reach the EIGRP network, it doesn't know it exists. That LSA has been blocked, and it's no longer on this router's database. So what we do instead is we advertise a default route into the router so that if I try to ping something up there, I know how to get out. Basically, this router has one way out, one way in. So I just need to send anything to the ABR, and luckily the ABR has all of the view of the OSPF network, so it knows what to do with it. So that's it. That's all it does. We're just filtering some LSAs, shrinking the database, shrinking the routing table, and injecting a default route. This was a fantastic idea. Cisco was like, you know what? I'll do you one better. Not only are we going to block the type 5 and the type 4, why don't we block the type 3 as well? We're going to call that a totally stub. We're going to still inject a default route, which we need. So now we've taken our routing table and we've really shrunk it, right? We got rid of all of the external and all of the inter-area routes as well. That's what we're talking about. We call that an extension, and so we inject the default. Make sense? Then somebody came along and said, yeah, I like your idea of a stub, but I have a situation here where in this area, I want it to be a stub, but I need to be able to redistribute. There's a weird thing going on down here. And someone said, yeah, you can't do that with a stub. There's a rule. If it's a stub, you can't redistribute. So they came up with a solution. They said, okay, we'll call it an NSSA area, not so stubby. All that basically means is it allows you to have within the NSSA a device that's been configured as an ASBR. In other words, it's just simply redistributing, right? Don't forget, that's all that is. An ASBR is a device that's redistributing something into OSPF. So now I'm doing something quite clever. I'm filtering stuff this way. What stuff? Type 4, type 5 LSAs. And I'm allowing these external routes to flood through this area and then keep going possibly as well. But notice something very, very special. I know I haven't talked about this one yet. It's going to use a very special kind of a unique LSA. It's called a type 7. But again, you're not going to find the type 7 everywhere. It's going to be very specifically just in here. And then when those type 7s hit this guy, they're going to get converted into type 5s, which the rest of the network recognizes as a regular external network. That makes sense as well. There's something a bit weird, though, about the NSSA. By default, it won't advertise a default route. You have to add an extra little command to then say, yes, please also advertise a default route. And I was talking to some of my colleagues about that, and the reasoning is that it happens quite often that you might actually be advertising a default route from the ASBR in here as well. And so you wouldn't want to have two default routes being advertised. So they're basically asking you as the network admin to make the decision. Do you really want a default route in there, or do you just not want to have one, okay? Again, really, really clever stuff, good idea. Someone said, yeah, but hang on. If we're filtering the type 4s and type 5s, we might as well filter also the type 3. So the totally stub, or the NSSA totally stub, does that. It's going to filter everything, right? Inter-area, the ASBR advertisement, the external routes. So nothing goes into the NSSA this way except a default route. So this time it will advertise the default route by default. We're still redistributing and advertising stuff, in this case, let's say from EIGRP, into the NSSA area. We're going to be using just the regular type 7 LSA that we just talked about to advertise them in here. And then when that type 7 hits the ABR, it gets converted into a type 5. That's it. That's as simple as that. So those 4 special areas, really easy to configure, like one little command on each router. Every router within the area would have to have the interface that it's connected to configured properly for that area as stub or NSSA, but very simple to configure, but very powerful at the same time because of this kind of LSA filtering that it's doing within that area. Make sense? Okay. I would have done through like this little walkthrough I put together. Let's quickly do it, okay? I don't know who's next after me. Let's quickly do it. Here's my topology. Nothing's been enabled. No stubs, no NSSA. Right now I'm looking at the R2 router, and look at all the stuff that's in here. External routes, inter-area routes, huge amount of stuff in the routing table on R2. I want to start shrinking that. So let's go. Step 1, let's turn area 1 into a stub. As soon as I do that, what did I say that would happen? The external routes are gone. Check. I'll just back up. E2, gone. Replaced by default route. That was good. Step 2, we're going to go totally stub on area 1. So keep an eye on this. What's going to happen? Very nice and clean. That's all I need. Default route. Beautiful. Works. How about this one down here, area 2? Okay, got a lot of stuff going on. I've got some externals here. I've got some external over here. Let's have a look. Looking at R3, right? He's learning loads of stuff. Lots of inter-area and an external. R1, I just put this one as well, just to show you it's learning a lot of external routes, all these 10 networks here, and then this 198, right? Lots of stuff on R1. But it's not really R1 I'm worried about. I want to work on R3 here. So I'm going to turn on NSSA. Okay, what happened? Hang on a second. Back it up. Okay, E2 is going to disappear, right? But notice what's missing? There's no default route. As I told you, if you want a default route, you enable it, and then it will inject it as an N2 entry at that point. So it's just so it's like area, whatever, 2, totally NSSA, and then you tell it to advertise the default route. Now, if I go totally NSSA, what's going to happen? If I do a show IP route, this is quite funny. Look how small the routing table went. This was the routing table on R3. As soon as I enable totally NSSA, 1 line. That's all. It's learning about the default route. It knows how to get out. Nothing has changed on R1. Everything has changed on R3, though. And so just keep that in mind as you're working through these. The point of the stubs and all of these funny areas is not to help the ABR. It's to help the routers in those areas. Minimize the link state database, minimize the routing table at the same time. Thank you very much for joining me. It's appreciated. As I said, if you're interested in the draw for my book, because you're thinking of taking ENCOR or ENARSI is fine. Just maybe wait for me on the side here as I pack up, and we'll do a little draw for the book. Is that okay? All right, fantastic.